All right. Hey everybody. How's everyone's semesters wrapping up? Great. Yeah, I hear mixed reviews of this courses going online thing from other classes, but I hope that you guys are at least uh enjoying this one. So this week I just put up the YouTube videos yesterday for Wednesday and Monday's session. Uh, for introducing FOPL, I wanted to make the YouTubes a bit shorter than they have been in the past. I think I I feel like personally it's easier for me to digest like a 10 to 20 minute YouTube than like a 50-minute one. So I tried to make it really concise. Uh, okay, so next week I'll be handing out the exams. So today's your last homework, and the last homework's due. It's basically just on FOPL, um, first order predicate logic, and then the exam's going to be everything else. I mean, including FOPL, but not. So it's not going to be cumulative. So it's everything after the midterm is going to be on the exam. It's a take-home exam, so it's like an assignment. You just have like a week to do it, and yeah. So you know, what will be helpful is paying attention to. So next Monday is our last Zoom session, I believe. I have to double check that, but it'll be like an exam review session. So I'll cover anything you guys had trouble with or struggled with on homeworks. So that will be a good guide to like for instance, if you had trouble with negation introduction, whatever the session's going to be, whatever you guys to focus on, whatever you guys need help with the most. Okay, so today to finish up FOPL, I'm gonna be just briefly going over the syntax of this new language, and then we'll cover the semantics today, and then that's going to be it for FOPL. So just to review, the syntax of this language introduces two new symbols, two new types of symbols, variables and quantifiers, and they all have their own properties and ways of talking about them that are unique compared to what we've learned in TFL. So the backwards E is the existential quantification, and the upside down A is the universal quantification. And on the YouTube I submitted yesterday goes over how we talk about quantifiers and their relationships to the well-formed formulas next to them. Quantifying over, closed well-formed formulas, and so on. All right, so today I'm going to go over the semantics of FOPL, so what these new symbols mean. So roughly, the upside down A is universal quantification. So universal quantification, and it's specifying that whatever variable it's next to means all, and then the backwards E is the existential quantifier, and it means some. All right. So truth in FOPL comes in the form of models. Model-based similar to how that's the case with TFL. And if you remember those extensional models, that's our understanding of truth in FOPL as well. But we won't be going too far into detail in this course. It's sort of like it's an advanced topic. Same with derivations in FOPL. So if you guys are interested in that sort of thing, definitely check out Philosophy 115. I know a lot of students who enjoyed 114, really enjoyed 115. It goes into, goes more into the theoretical side of logic. Okay. So let's just imagine a casual model. So a casual extensional model of gastropods. So gastropods are things like snails, limpets, slugs, conchas, and whelks. So let's just consider that basically the domain of our model. That set of 5 things. All right, and now we're going to specify the predicate. So normally we would be saying what the extension of these predicates are. We're just going to say roughly what these predicates or properties mean. So D, for instance, we're going to specify as existing on land. I actually have no idea out of these 5 which ones exist on land and which ones don't. Some of them are in the sea, some aren't. C, the predicate C is existing in the sea. We're going to have a 2-place predicate, BXY. So it's going to assert that X is bigger than Y. So the first place is bigger than the second place. And then M is the predicate for yummy. And I assume that's all gastropods. I've only eaten snails. I found them pretty disgusting, but whatever. And we're going to have 2 names. We're going to have L for slugs and N for snails. So for instance, the predicate MN translates to, in our casual model, snails are yummy. And then the atomic predicate, BNL, is snails are bigger than slugs. Is everyone cool with this casual model so far? Oh, hey, Maddie. All right. So I'm going to show you guys how we can have a casual understanding of quantifiers coming from this model. All right. So quantifiers tell us how many things the variable in its scope refer to. So for instance, the existential quantifier quantifying over y, if we insert a variable y in the first place of that 2-place predicate b, roughly means there's at least one gastropod, y, that is bigger than snails. So this is a common way of translating the existential quantifier into everyday language. It's saying there is at least something. There exists at least one thing that has this property. All right, in the domain, right? So our domain we're talking about is gastropods. Okay. Existential quantifiers specify that all things that could possibly fit into X, which is everything in the domain, lives in the sea. I mean, sorry, it has that property. So universal quantifier X, CX, translates to roughly, in our casual model, every gastropod lives in the sea. Existential CX translates to something as sea. At least one species of gastropod lives in the sea. We don't know which one, so it's not saying, for instance, snails. It's saying there's one out there, we don't know which one. All right, and here's where we can do some tricks using negations in order to cover more ways we would talk about categories of things. So just to pause for a second and to notice what FOPL is letting us do, it's letting us talk about categories and how groups of things fit in those categories in a way that TFL really doesn't, right? Well, TFL, we had names that referred to individuals. Now we have variables that can refer to, that are more flexible. They can refer to groups or, nothing, and so on. So it allows us to talk about, for instance, everything is not or nothing is using a negation. So if we say something like universal quantifier x negation cx, that means roughly everything is not C. Everything in the domain is not C. So every gastropod does not live in the sea, or no gastropods live in the sea. And then if we negate a well-formed formula with a existential quantifier, that allows us to say that there's something that's not C, or something that there's at least one gastropod that does not live in the sea. So these ways of translating well-formed formulas into English from FOPL and then back again are going to be the last thing you guys will have to do for homeworks and also the exam. So it's like the last skill we're learning in this class. All right, so I prepared sort of a visual way of understanding how predicates operate with variables and how we use FOPL to talk about categories. So in a model like the one we're looking at here, where we've got a domain, it's got several species of gastropod in it, and we've got certain predicates, and they've got a meaning. They've got some extension. So you can imagine dx, for instance, has in it the list of all gastropods that live on land. All right. So you can think of predicates as categories of the domain. So we've got, for instance, this category we can call, like CX. So we might have snails, or one gastropod that doesn't live in the sea, but we've got whelks in here. So you can think of them you can think of these predicates in terms of Venn diagrams. A sort of useful way to think of the semantics of this language. All right. So we can have, we're going to be using compound well-formed formulas to talk about sort of more complex assertions using categories. So if you remember, these two by themselves would mean, so existential x dx means there's some gastropod and it lives on land. There's at least one gastropod that lives on land. Existential x cx means there's at least one gastropod and it lives in the sea. So what would it mean if we used a conjunction? So if we're going to combine them in a conjunction, it means that there's at least one species that lives on both land and sea. So maybe that's snails, right? So a way to think of the meaning of this compound is it's of the conjunction specifically. Oh God. Is it's over an overlap of two Venn diagrams. The predicate of the predicate that's referring to all the land, where the extension is all the land gastropods, and the predicate where all the that has as an extension all the C gastropods. And then this well-formed formula here is asserting that there's at least one species that lives in this like overlap between the two. So that's the meaning of this compound well-formed formula in FOPL. Okay, and here, how do we talk about, so this is, just to go back, this is a really common way to use existential quantifiers to talk about categories or to assert facts about categories. So you often, when you're talking about an overlap of categories using the, you're going to be using a conjunction. All right. So another common way to talk about categories using compound well-formed formulas for universal quantifiers is using the arrow. So in TFL, the arrow sort of meant something similar to entailment, right? If the first is true, then it's saying that would mean the second has to be true, the second part, the consequent. If you think about that way of expressing a fact about categories, it's a way to say something along the lines of all of the, if something's in this category of D, then it has to be in C, right? Which means is another way to say that D is a subset of C. So all the, all the land gastropods, snails, slugs, all the land gastropods are also exist in the sea. So all land gastros exist in the sea. So if you're going to talk about how all of, using this universal quantifier, all of something is actually another thing, then you would be using this really common way of asserting a fact in FOPL. Yeah, so these are what you can call as categorical well-formed formulas. So they're ways to talk about categories of things using the new tools we have at our disposal, quantifiers and variables. So the one way is to use a universal quantifier with an arrow, and that's a way to express all D's or C's, for instance. So all of one category are another category. All land gastropods also live in the sea. A conjunction combined with an existential quantifier allows us to express some D is C. So at least one land gastropod lives in the sea. There's like at least one thing in that overlap between the Venn diagrams. So these well-formed formulas are false if, in fact, in the domain, maybe one gastropod does not live, one land gastropod does not live in the sea. So that's how the model determines the truth of these, well-formed formula. So flipping things around with negations, we can express these facts. So for instance, no D is a C, no land gastropod lives in the sea. Or some D is not C. So at least one land gastropod does not live in the sea. All right, I'm going to be uploading these slides to Blackboard to help you guys out. Because it can be sort of confusing. It's not really a way we've used logic yet. This is, maybe if you're getting the sense that this is like a really, starting to be a really detailed and maybe like refined way to talk about things using logic. It's actually what so there's this really interesting area of AI technology and database development called ontology, where engineers are really concerned with coming up with these sort of sentences for machines to parse and um, chunk up reality. We're starting to get to like a really fundamental and also practical use of logic that's like used in top end companies right now. Okay, how to read categorical well-formed formulas. So using negations, we don't have to be limited to the predicates in our model. We can in fact come up with new categories. So for instance, if you remember, we've got this predicate that has in its extension all the delicious gastropods. Well, if we negate that, we can talk about disgusting gastropods, right? Even though that's not something that's given to us in the model we came up with. So we can assert facts like disgusting gastropods live in the sea using a negation. All right. Do you guys have any questions so far about what we've covered with this sort of casual interpretation of quantifiers?
Will we be given like a word model, or will we just be given like a welcome formula and kind of have to sort it out?
So you guys are so in a question about these things, like on the homework, you're given something like this. So you're given this model and like a casual interpretation of the predicates. And then you either have to translate from a well-formed formula like that to English, or from English back to a well-formed formula like that. Yeah. All right. So let's do that together, actually. I made some really complex ones here. I really hope this. Oh, yeah. So I messed up on the homework. I made one of the things we're doing that was graded part of the ungraded homework. So just consider that like graded, I guess. That was my bad. Yeah. Okay. So, okay, this is the same model we've been using so far with gastropods. So let's try and translate this first sentence into a sentence about this first well-formed formula into an English sentence. All right, so starting from the first part here, we know universal quantifiers with arrow symbol are a way to express this sort of Venn diagram, right? So it's saying that all land wait, no, sea. My bad. So all sea gastropods are yummy. And then the second part here, we'll translate that part next, is saying there exists one non-sea gastropod that is yummy. So at least or some, at least one yummy gastropod doesn't exist in the sea. Okay, so we've got the two components of that biconditional written down now. And the biconditional here has the same sort of casual interpretation it has in TFL, if and only if. So the if with two Fs. So all sea gastropods are yummy if and only if at least one yummy gastropod doesn't exist in the sea, is what this sentence translates to. All right. So that was sort of a tough one to start off with. That's like the toughest translation that I would give you guys, or that you would have to do. All right, the second one says something along this lines. So we've got M, which means yummy gastropods, B, which is bigger than. And so let's concentrate on this categorical well-formed formula here. I'm gonna write it up at the top since I ran out of space. So all yummy gastros are bigger than slugs. So the X that is being predicated this yumminess property is also the same X that is being predicated this in this bigger than. So the fact that both those X's are in the scope of this quantifier means that that category that the predicate is asserting to everything is the same. So it's possible for, one thing that's possible that might confuse you guys is to have two universal quantifier X's inside the brackets. And that would be asserting that those things are different. It would be something like, there are all gastropods are yummy. If all gastropods are yummy, then all yummy gastropods or all gastropods are bigger than slugs. Sort of like nonsensical. It's very possible to come up with nonsensical well-formed formulas, or at least well-formed formulas in FOPL that would never be used in English as assertions, but that are still legitimate. I mentioned this in the YouTube yesterday, that sort of like this idea of assertions we would actually make are, TFL captures a lot of that and doesn't really make assertions. You can't really make assertions that we wouldn't make often. In FOPL, it's very possible to do that, to make sort of nonsense assertions. But that are still well formed according to the language. Okay, anyways, so that was a bit of a digression. Second part of this. So all yummy gastros are bigger than slugs, and snails are bigger than slugs. All right. And lastly, what we're going to do is we are going to translate this English assertion into a well-formed formula. So all gastropods that are bigger than snails are yummy. So it's talking about two categories of things and how all of one category is in fact part of another category. So the way we use that is this categorical well-formed formula, universal y. The variable doesn't matter, but what does matter is we've got the bigger than predicate. So it's asserting that y is bigger than L, which is snail, no, N, which is snails. And also that snails are yummy. So, all right, sorry, that all the gastropods bigger than snails are yummy. There we go. That's the first part of that well-formed formula. And then the second part, and some gastropods that are not sea gastropods are yummy too. So the way we assert this fact, glue that together with the and, conjunction, gastropods that are not sea gastropods. I forgot to put the quantifier on the outside. This is important for these categorical well-formed formulas. So quantifier x. So some gastropods that are not sea gastropods, negation c x, are yummy too. There we go. So we translated to English, from English to FOPL using these categorical well-formed formulas. And here is that list again. So I'm going to post this on Blackboard so you guys can look at this to help you out with your homework. But that's basically it for today. Do you guys have any questions?
I have a question about the homework if we're doing homework questions too.
Yeah.
I'm just confused how you can determine if something is closed or open if it doesn't have a variable in it.
Oh, okay. Right. So there's some homework questions that are a little bit tricky.
Like the third one right there.
Right. Okay. So I'm going to go back to our definition of closed and open. Right. Okay. So the definition of closed is any well-formed formula that has no free variables. So that question is sort of tricky because it's not one with any variables, right? So it's just closed because of that. Does that make sense, Judson?
Yeah, it does. It was just kind of like tricky because I feel like it could kind of go either way because like based on the definition.
Yeah. I mean, yeah, it could be defined either way, right? So we could say open's like one with, no quantified variables or something. And that's true here as well. But so this is, I had to look it up myself too, because It's not intuitive, but it is closed. So close and open refer to, so something's closed if there is no free variables. Otherwise, it's open. And this one just has constants in it. Yeah. Oh yeah. So another thing, I'm gonna give Thomas a copy of last year's exam just so he can know what stuff to review with you guys. So yeah, that should. Yeah. So you know, get in contact with him. Go to those SI sessions and such. All right. Any other questions? Nope. All right. Well, good luck with the homework, guys, and I'll see you all Monday.
Thanks. Bye.